So we are on chapter number 4, gas. Great, now we know how to update key portion of the app while preventing other users for messing with other our contracts. Let's look at another way. Solidity is quite different from other programming languages. Guess the fuel Ethereum DApps run on. Solidity, your users have to pay every time they execute a function on your DApp using a currency called gas. Excuse me. Users buy gas with Ether, the currency on Ethereum, so your users have to spend Ether in order to execute functions on your DApp. How much gas is required to execute a function depends on how complex the function logic is. Each individual operation has a gas cost based roughly on how function computing resources will be required to perform that operation. Example, writing to storage is much more expensive than adding two integers. The total gas cost of your function is the sum of the gas cost of all its individual operations. Okay. Because running function costs a real money for your users, code optimization is much more important in Ethereum than in other programming languages. If your code is sloppy, your users are going to have to pay a premium to execute your function, and this could add up to millions of dollars in unnecessary fees across thousands of users. So whenever a user call a smart contract function that do some transaction means that writing to the blockchain, so it will cost a gas to the user, the one who is calling it. So we have to make our code optimize so that user don't have to pay so much amount in the gas fees. Why is gas necessary? Ethereum is like a big, slow, but extremely secure computer. When you execute a function, every single node on the network needs to run that same function to verify its output. Thousands of nodes verifying every function execution is what makes Ethereum decentralized and its data immutable and censorship resistant. The creator of Ethereum wanted to make sure someone couldn't clog up the network with an infinite loop or hog all the network resources with really intensive computations. So they made it so transactions aren't free and users have to pay for computations time as well as storage. So that's a great idea that uh, in which user anyone can't be clog up the network with infinite loop or just do unnecessary calls, because every call have a fee, every transaction has a fee, so no one can just call uh, unnecessary function. If they call unnecessary function, they have to pay the gas fees. So that's one of the reason why they have add the gas fees. This isn't necessarily true for other blockchain like the one the crypto zombie authors are building at Loom Network. It's probably probably won't ever make sense to run a game like World of Craft directly on the Ethereum mainnet. The gas cost would prohibitively expensive, but it could run on the blockchain with a different consensus algorithm. We'll talk more about what types of dApps you would want to deploy on Loom versus the Ethereum mainnet in a future lessons. So there are other network, network other than mainnet, which have lesser gas fees. So we will do how we can deploy our smart contract on these to save on gas. Struck packing to save gas. In lesson 1, we mentioned that there are other types of U in 28, 16, 32, etc. Normally, there's no benefit to using these subtypes already. reserved to 56 bits of storage regardless of uint size. For example, uint 8 instead of uint 256 won't save you any cache, but there's an exception to do this inside a struct. Okay. If you have multiple uint inside a struct, using a smaller size uint when possible will allow Solidity to pack these variables together to take up less storage. For example, struct normal struct uint A, uint B, uint C. Struct minimum uh, uint 32, uint 32, uint. Mini will cost less gas than normal because of struct packing. So uh, uint, as we know that uint is default for uint 256. We have other types also, uint 8, 16, 32, and so on. Uh, just use these will not save you gas, but as we use them inside the struct, it will going to save you gas. That's the example. Normal struct not saving you much gas, but this minimi will save you more gas because we have defined the uint 32 inside it. For this reason, inside a struct, you'll want to use the smallest integer subtypes you can get away with. You'll want to cluster identical data types together, that is, put them next to each other in the struct so that Solidity can minimize the required storage space. For example, a struct with uint C, uint A, uint B, uint 32B will cost less gas than a struct with uint 32A, uint C, uint 32B because the uint 32 fields are clustered together. Okay. The ordering is also important here as it defined here. For details in this lesson, we are going to add two new features to our zombies: level and ready time. The latter will you implement a cooldown timer to limit how often a zombie can feed. So let's jump back to zombiefactory.sol. Add two more properties to our zombie struct: level uint 32 and ready time also uint 32. Let's add them. Uint 32 level uint 32 ready time. Okay. Okay. We want to pack these data types together, so let's put them to the end of the struct. 32 bits is more than enough to hold the zombie level and timestamps. So this will save us some gas cost by packing the data more tightly than using regular uint 256 bits. So let's check the answer. Yes, it's correct. So we have completed 4 chapters. Now let's move on to chapter number 5.